Hey guys, welcome back to another math lesson. Hey, real quick, what do you call dudes who love math? They're algebros. All right. We'll go ahead and get going. I hope you guys are doing well, staying healthy. We are doing good. I have my kids busy doing Zoom play dates to keep them, I don't know, not attacking each other all the time and wrestling each other all the time. So distracted, that's the key word I'm thinking of. Alrighty, we'll go ahead and get going with these notes today. And what we're talking about, I have it at the top, symmetric versus skewed data, or you could say symmetric versus asymmetric data. What I have right here are different shapes of data distribution. We have talked about and worked with dot plots, histograms, box plots, but the way that they are created, there's a lot of information by just looking at it that we can get from it. But before we get into that, I just want to talk a little bit about the vocabulary. So what I have here first, and I know it's kind of hard to pronounce, it's not the best image that I could get, but when most of the data is near the center of the range, the shape is called symmetrical. Next, we have this dot plot, and again, this works for dot plots, histogram, box plots, but when the tail, so this is called the tail, when the tail is like trails off to the left, that is called left skewed. So tail on left, we'll write that in there. And then lastly is we have something called right skewed, and this is called right skewed because, again, the tail is tail trails to the right. Can you guys see that? There we go. And real quick, we'll see that it's easily confused because you see the data points are clustered to the left, but again, it's right skewed because the tail trails to the right. All right, the next thing that I want to talk about this is, we talk a lot about our measures of center. The most common ones that are used is the mean and the median, and we use that a lot with symmetric versus asymmetric data. And this part right here is important. When it is nearly symmetrical, okay, the mean and the median are approximately equal. Okay, so they are approximately equal. When the data distribution is not symmetrical, okay, often described as skewed, I'll be using that a lot. Obviously, hopefully, obviously, the mean and median are not the same, okay? And then this last part is going to be a lot of your questions on the Google Forms. So when we are given symmetrical distribution, the mean is your appropriate choice for describing the typical value. Okay. When we have skewed data, right or left skewed, the median is a better description of the typical value. Okay. So let's go ahead and get through some of these examples and you'll see a little bit more of what I mean. So what we have here first, this would be considered symmetric data. So even though it might look like it tails a little bit to the right, this is considered pretty symmetric. So with my, when it talks about the shape, this is where we are going to go ahead and write in, say this is symmetric data. Okay? And it's symmetric data because the data is distributed around the center. Okay. Then I'll be asking you, well, which one is a more appropriate value to describe this symmetric data? And you're going to say, oh, well, the mean is the more appropriate value, even though right now, and we're going to remember that the mean and median are almost equal. Oop, there we go. Just real quick, when we have symmetric data, mean and median are almost equal. Next, again, I'm going to be asking, how could you describe this shape? And, well, we're going to take a look at where that tail is. So we see everything clustered to the left, but what's important is we see that the tail of this distribution, it trails to the right. Okay, so again, that tail trails to the right. So that means that the shape is called right skewed. Okay, and then I'm going to ask, well, what is better to describe the typical value of this histogram? And you are going to say, well, the median, okay? Because when we think about all of these data values, and there's going to be about 100, that's what this n equals up here is top. The median, the middle value, is going to be probably closer to where most of the values are. But when we have some very high numbers, sometimes they're considered outliers. And when we have those outliers, it makes the mean like skewed. It makes it thrown off. And so for this one, we'll just say the mean is a greater value than the median. Good, I'm not cut off this time. We won't be writing this explanation in every time. We're going to just do it for the first two examples. Okay, once you have that copied down, let's go ahead to the back. The back, just a couple of quick problems. There we go. My papers were sticking together. So now I have a box and whisker plot. Again, my question is going to be, what is the shape of this? Well, this is asymmetric, but I want to know when it's asymmetric, is this left or right skewed? And so we'll go ahead and say this right here, this is considered the tail. And the tail goes to the left. Okay, and so this is called left skewed. And when it is left skewed, what is better to describe our data? Is it going to be the mean or median? And you're going to remember the median is better to describe the data. Okay, and you can really see that right here. Next, let's go across. What is the shape of this? And you are going to say that the data is distributed symmetrically. So we have a symmetric data distribution. And then what is going to be a better value to describe this data? And you are going to tell me that the mean is better when it's symmetric. Okay. My next example is a dot plot. Okay. For this dot plot, is this considered symmetric or asymmetric? And you are going to tell me that this is asymmetric. Okay, with it asymmetric, we have a tail. Tail trails to the left. So this is called left skewed. Again, which one is better to describe this data? And you're going to tell me when it's asymmetric data, when it's left or right skewed, the median is better to describe this data. Next, again, what kind of data distribution do I have here? Well, on this one, this is considered symmetric. Okay, my data is about the center. So this is symmetric. And of the two, which one is better? It's going to be the mean will be a better way to describe the data of this distribution. The last thing that I have right here is the definition cluster, or the vocab word cluster with its definition. You heard me talk a little bit about it in this video, so I just want to remind you, this is when data seems to be gathered around a particular value. So we'll see the clusters on the opposite side of skewed data. One last thing I want to leave you with is I posted in the Google slide another short video that goes along with this topic. I think it's only 4 minutes if I remember correctly. I highly recommend that you watch it to get a better understanding of this topic. Okay? All right, that's it from me today. I'll see you guys another time. Take care.